proximal end of the nail and remove it using the sliding hammer. The Missa-nail system is intended primarily for the treatment of ipsilateral shaft and femoral neck fractures. This system enables the surgeon to stabilize lateral femoral neck fractures by the insertion of large cannulated screws or 6.5 millimeter cancellous bone screws in lag fashion, aiming past the nail. If the femoral neck fracture is to be treated before the shaft fracture, a short dummy nail is used. The Missa-nail aiming jig guides wire placement for insertion of the cannulated screws. The Missa-nail aiming jig can be screwed onto the specialty aiming arm at different angles, depending on the femoral neck and fracture angles, namely 100, 110, 120, and 130 degrees. Typically, the screws are placed anterior to the nail. However, if the nail has been inserted too far anteriorly, the Missa-nail procedure can also be performed posteriorly. The aiming jig accommodates the 2.8 millimeter wire sleeve for the cannulated screw, or the 3.2 millimeter drill sleeve for the regular cancellous screw. The distance between the two screws can be adjusted with the aiming jig to suit the width of the femoral neck. The sleeves then are locked in place. With the insertion assembly, insert the dummy nail and connect the specialty aiming arm. For this exercise, select the 130-degree position and mount the Missa-nail aiming jig onto the aiming arm. Insert the 2.8 millimeter drill sleeve with trocar. Correct the handle for the anteversion of the femoral neck. Remove the trocar and insert the 2.8 millimeter guide wire. Repeat the procedure for the second wire. The distance between the two screws is determined using the image intensifier. However, in this exercise, we simply place a K-wire on the neck. Remove the specialty aiming arm. Using the direct measuring device, determine the length of screw necessary. In most cases, the self-drilling cannulated screw can be inserted without pre-drilling. In young, dense bone, however, the cannulated drill bit is used to pre-drill the near cortex, as is shown in this demonstration. Next, insert the self-drilling titanium cannulated screw of the appropriate length. Repeat the procedure for the second screw. The use of a washer is optional. Although the screws can be inserted with the dummy nail still in place, it is recommended that the aiming instruments and dummy nail be removed before inserting the screws. Alternatively, the Missa-nail technique can also be used after the unreamed nail has been inserted. Remove the guide wires and the dummy nail. Insert the nail as described earlier. The insertion handle has an etched line and a hole through which a pin may be passed to determine the position of the proximal end of the nail. Next, insert a 5 millimeter gold-colored cancellous screw through the dynamic slot at the same angle as the Missa-nail placed cannulated screws, using the specialty aiming arm, 3.2 guide wire, and sleeves. Connect the specialty aiming arm. We will use the 130-degree retrograde hole. After inserting the sleeve, drill a hole with the 3.2 millimeter calibrated guide wire. Finally, insert a 5mm gold-colored cancellous screw. The diaphysial fracture is then controlled by placing a green locking bolt through the static hole in the nail, using the standard aiming arm, 4mm drill bit, and sleeves. After inserting the locking bolt, remove the insertion assembly and place the green end cap into the nail. The end caps are available in various lengths, so that the level of the proximal nail end can be adjusted if necessary. Note that the final portion of the threads are scarified to prevent loosening. This will produce additional resistance as the end cap is screwed into the nail. Insert and tighten the end cap. The final appearance of the locking configuration. The cutaway model shows the positioning of all locking bolts.